Hi everyone, welcome to your week 2 lecture for the stats stream of 105. So this week we're talking about some introductory statistical concepts. Some of it will be revision for you guys if you've done PSYC 104, and I'll talk a little bit about that throughout the lecture, about where those of you who haven't done 104 can go to get some extra resources if you feel like you're missing out on some of the fundamental stuff. So the things we're talking about today, basically a whole lot of words, a whole lot of definitions of things. Hopefully you'll stay awake, fingers crossed. It's not the most exciting lecture, but I will do my best with the aid of amazing stats memes to help keep you engaged. So I'll start talking off about a couple of important things, so like the distinction between a sample and a population, a parameter versus a statistic, and descriptive statistics compared to inferential statistics. We'll also talk about different kinds of data that can be collected, which is quantitative as opposed to qualitative data. We'll also talk about different sorts of levels of measurement, so different kinds of variables that you can have, those being nominal variables, ordinal variables, interval variables, and ratio variables. And there'll be a little bit of recap about study design or research method design. So because most of you, the majority of you, have done PSYC 104, where research design and research methods are covered, we don't go in nearly as much detail in this course because it would just be doubling up for a lot of you. But as I said before, I'll give those of you who haven't done 104 some specific resources that you can go to if you feel like this is too brief of an explanation of these concepts. Okay, readings and quiz for this week. So as every week, you have a chapter out of your textbook, which is the Top Hat textbook, which is compulsory reading for these particular lectures. Here it's a week 2 reading because we are in week 2. And you also have a quiz, which is also in your textbook, that applies to this particular lecture content. So the quiz, as always, for each of the weeks, starting in week 2 this week. The quiz will open 9 a.m. Monday morning and it will close 5 p.m. Sunday afternoon. These are some of the resources I was talking about. So if you want extra resources on research methods stuff, then the first place that you can go to is chapter 2 of one of the PSYC 105 textbooks, the Lillienfield textbook, which is your psychology content textbook. So it's a different one to the stats book. But chapter 2 talks all about research methods, so that gives you a really good overview of different kinds of study designs, which is important for you to understand the kinds of things we're talking about in statistics. If you have done Psych 104, which is Intro to Psych 1, then you'd also have all of the materials that formed the research design part of that course. So you had lectures, you had a textbook that went along with those lectures. So revising that content in terms of different kinds of research designs, different sorts of study designs, is a really good idea before going into this particular content that forms these lectures. This is a recap, and it's a very similar slide to one that I had up last week, which is the scientific method slide. It was a little flow diagram of the scientific method. This is essentially just outlining the processes that you would go through if you want to answer some kind of research question. If you are interested in finding out something new about the world, something that hasn't been investigated or doesn't have any information about it yet, and you wanted to collect some data to see if the data or the world is consistent with your particular research question or your particular predictions about the world. So you would start off with your research question, step 1, which is what is it that you're actually investigating? What is it that you're interested in? What is it that you want to find out? My research question could be to identify the most effective ways to study for a unit. My research question could be learning the different kinds of treatment that are most effective for people with depression. My research question could be trying to understand if people with more neurotic personalities experience more anxiety. It's a general question that is the thing that you're interested in. Based on your research question, you then make hypotheses, which are predictions about what you think is going to happen or what you think would be the case, what you think is the association between certain things you're interested in. So hypotheses are these predictions that you've got, which is a prediction or a guess about the way that you think something would happen. So whereas a research question tends to be quite general and it's phrased in terms of a question, a hypothesis is a specific prediction or a guess about how something would be. So if my research question was to understand the most effective treatments for depression, then my hypothesis might be that psychological treatment, psychotherapy, is more effective than pharmacological therapy, than antidepressant drug therapy. So a hypothesis is a prediction. Step 3 is about operationalizing the construct, and what that means is, of the things that you're interested in, how are you specifically going to measure them? So if I'm looking at the most effective treatment for depression, how am I measuring depression? What's going to be my measure of somebody's depression level? Is it asking them a question, how depressed are you? Is it using a psychometric scale that might have 20 items of it to measure different aspects of depression? Could I use some kind of neuropsychological test to measure depression? So operationalization is thinking about how you're actually measuring the stuff that you're interested in. Step 4 is then about designing the study itself. So what kinds of research methods are you going to use to be able to get information to answer your hypothesis or to evaluate your hypothesis? So the study can be lots of different kinds of studies, some of which we'll go over today. There's lots of different ways of designing a study, an experimental study or a non-experimental study. But you need to think about what study design is most appropriate for your research question and for your hypotheses. Step 5 is then about collecting the data. So you need to gather information in the form of data that you can use to address your research question and your hypotheses. So if I was interested in the effect of different kinds of therapies on depression, I'll need to collect data on people's depression scores. I will need to collect data about the kind of therapy that somebody was engaged in, maybe the dose of the medication if they were taking medication, maybe the number of sessions that they saw with the therapist, collecting the information in the form of numeric data or quantitative data. Step 6 is where the stats comes in, and this is our analysis step, so actually using statistical methods to analyse the data. And we'll be talking obviously throughout the rest of the semester about how exactly we go about doing that, but that's it in principle. It's the analysis step. And then step 7 is about drawing conclusions. So based on the results of the analyses, did we have support for our hypotheses or not? What's the answer to our research question? What have we learned that we didn't know already? What have we found out about the world that wasn't already known? And most of this course is going to be step 6 and 7. You can't do step 6 without step 7. So obviously once you analyse the data, you need to then understand what that means, what the answer is. And we'll be talking about multiple different kinds of statistical analyses that we can use to address step 6 here. Okay, so research design is really important. Statistical methods are really important, and obviously they go together in terms of using statistical methods to analyse data which has been collected through a research design. But in terms of the two, my opinion, and I'd probably say most people's opinion, is that research design is actually more important than statistical methods. And the reason for that is there's lots of different ways you can analyse data using statistical methods, but if your data don't come from a well-designed study, if your study design isn't appropriate to the research question, no statistics can save that. No statistical methods can actually overcome those problems that have been brought about by having poor research design. So research design comes first, statistical methods come afterwards, and if you've made a mistake with your research design, you're kind of screwed. There's nothing you can really do to overcome that or to try and fix the problems. So research design is probably more important than statistical methods, and I say that